Hello friends, welcome back to Learn-It tutorials. This is our sixth video in our Terraform tutorial series. So far, we have covered lot of topics that starts right from the basics. So in this video, we are going to talk about Terraform conditionals, built-in functions and loops. This is going to be super useful, so don't skip the video, watch till the end. I have provided all the relevant links in the description, make use of it. I have already uploaded many technical videos on different technology and tools. If you are interested in learning, then please do subscribe now and click nearby bell icon so that you will get the notification of the new videos. I am using Visual Studio Code for working with Terraform resource files. I have created and used a few directories already. For this topic, I have created a new directory called tfproject2. I have added a provider file and specified the region as US East 1. So I will be using a single file here called ec2.tf where I will be adding all my resources and will go through one by one. So all these basics are already covered in the previous topics. What is Terraform conditions and why do we use it? So when you want to set some values based on some conditions, there we will be using Terraform conditionals. This is like if-else conditions in any programming language. Like if the condition is true, then some task will be performed. If the condition is not true, then the other condition will be performed. Similarly, in Terraform, conditionals also help us to set a value based on a condition. The format is condition true value : false value. So if the condition is true, it will pick the first value, what you have mentioned here. If the condition is false, then it will pick the second value after the colon. This logic can be applied wherever you want to set a value based on condition. Here, I have a variable section as well as a resource section that we will be using to create a EC2 instance. So here we have defined the resource section. So this resource will be creating a AWS EC2 instance. So AWS instance is the resource name and web1 is the instance ID. Also I have specified all the basic parameters like AMI, instance type, subnet ID, key name and EBS volume size, associate public IP address, security groups and tags. Here if you see this instance type, I have referred my variable called environment. So the value what is mentioned in the variable environment will be set here for the instance type. Here the value would be Dave. Generally we will specify the values directly like type of instance, T2 micro, T3 medium or X5 large, something like that. Even in tags I have referred my variable environment. So the default value is Dave. So Dave will be set in this tag. Okay, let's see how we can implement this condition like a real-time example. This resource section is for one instance. By assuming this resource section itself, we know that this is going to be create a single instance and for Dave environment, because on the tags we have mentioned to set the name like environment and the value would be Dave, which means this instance is dedicatedly creating for the Dave environment. Let's say we want to create multiple EC2 instances for different environments. On that case, what we will do, we will just copy this resource section and duplicate it, and accordingly we need to update the values based on the requirement. Let's say I'm going to create this resource for production environment. So I need to change the instance name to something else. I cannot have same ID. So I will change this to web2. Let's have the same AMI. Okay, in instance type, let's say since it is a production, we will use some heavy instance type. For example, X5 large or something else. For example, let me use T3 medium. So subnet ID, if you have a different subnet, then you can change the value accordingly, and key name can be same. And if you want to increase the EBS volume from 10 to 50 GB or 100 GB, then you can change it accordingly. Okay, so if you see, I have a two resource section. One is for dev environment and other one is for production environment. So in this case, we need to think logically that I need to simplify my code because the resource section is common, but only thing is there are few values are different for the production environment. So here we need to think smartly and we need to consider whether we can implement the conditions here or not. Okay, let's apply the condition here. This is a dev environment. Then the instance type should be T2 micro. If it is a prod environment, the instance should be T3.medium. So let me remove this value. First, we'll call the variable environment because the condition should be like if the environment variable is prod, I need to set a value. If not, I need to set a different value. So here the condition is var.environment equal to, which is double equal to, and within double quote I need to specify the value. If it is a prod, then I need to set a T3.medium. If it is other environment, it's not only a dev. If it is a QA or if it is a UAD, I can go for a low instance type. So I will start my condition with production. Okay. So var.environment equal to prod, then I will give you the true value. Okay. Which is T3 medium. Then colon. If the environment is not prod, then what instance type I should give? It is T2.micro. So if I set my environment as a prod, then the instance type would be T3.medium. If anything else, then the instance will be T2.micro. So you can apply this logic wherever it is possible to apply it. Let's save the file and apply the configuration. I am already inside the directory and already have initialized my Terraform. So I just run Terraform apply. If I do Terraform apply, at the moment the variable environment value is dev. So if I do apply, the instance will be created like T2.micro because the condition is false. So instance is created now. Now go to your EC2 console and refresh the page. The web server 1 is created already and the instance type is T2.micro. We have not passed any argument for variable. We simply apply the configuration with the default value. Let's say I want to create an instance for production. So we have already a condition logic in place. So you can override the environment variables in two ways. Either you can modify the default value in your Terraform file, or directly from the command line we can use the -var flag. So -var within double quote environment equal to prod. So if I go with this -var flag, the environment value in the default will be overwritten with the current value I given in the command line. If I run this, the condition will become true because the environment is equal to prod. Then obviously the Terraform will pick the first value, that is T3.medium. Already we have launched an instance with this resource. So let me destroy it first with auto approve. So it won't prompt me for to enter yes or no. Again refresh the EC2 console. So instance is terminated now. So now again we'll apply the Terraform along with -var flag. It is applied. Refresh the EC2 console again. Now if you see the another new instance is created, now the instance type is T3 medium. That is because our condition is true. Based on the condition, it has taken the correct value. So this is what the conditionals in Terraform. So you need to think smartly and apply the logic if possible. Using these kind of features, we can simplify our code better. If you want to know more about the Terraform conditional, then search it in the search engine, and here you will have the HashiCorp official website link. You can go through all these things. Then we'll talk about loops. Loops are used when you want to create multiple resources of same type. So instead of copy pasting the same block many times, we can use loops smartly to simplify and scale it. For example, let's say you want to create 10 S3 buckets. So we will be using the same resource section and we will duplicate it 10 times. Similarly, if you want to create 10 EC2 resources, then you will copy and paste the resource section 10 times and you will update the values accordingly. Since you have the same type and resource section, then we need to think whether we can apply the logic of loops or not. So in Terraform loops can be achieved in two ways. One is count and for each. Count generally based on the numbers. Let's say 10 or 8. If I say 8, the loop will be executed continuously for 8 times. As we give 8, in the programming language, the value will be starts from 0, which means 0. The next loop it will be 1, on the next loop it will be 2, it will keep on go till 7. So obviously we will have 8 numbers here, but in the programming language it will start from 0, which is the index. We call it as an index. Okay, so index starts from 0 till 7. That is why it is a 8. If I say it is 2, then I will have the index values like 0, 1. If I give 3, then 0, 1, 2. Then for each will allow us to give the values, not like the numbers. Okay, for example, in a list we need to specify the values like web1, web2, web3. If I want to create a 3 EC2 instance, if I want to create a users, then I can specify the usernames in a list with comma. So again, for each time one value will be picked and the resource section will be executed. Then again the loop will continue and it will take the second value. Then again it will execute the task. Okay, let me remove this. Let's use the same example of creating the EC2 instance. Let's assume like for 10 EC2 resource instance or 3. As this is a demo, we can go with the small numbers. Okay, let me create one more variable to specify my values, like EC2 underscore names. And here in this value, within the list, I will define the values like web1, web2 or anything else, db1 and app1. So 3 servers. So this is what I am going to do. For dev environment, I will create 3 instances. It's like a 3-tier architecture, because in an environment we will have web servers, application servers, database servers. So for dev environment, I am going to create 3 instances. If you want to create different names, obviously you can go with that, like web1, web2, web3 or anything else. Now in the resource section, this is the same resource section what we have used for general EC2 creations, right? If you want to implement a loops, then we need to add just what kind of loop. So I will go with the for each first. So for each, if I give this for each itself, then Terraform will understand that we are going to perform something in a loop. So for each, now we need to bring the values here. To bring the values from the variables, we need to define to set the values. Okay, to set within the bracket. Now we can call the variables var.ec2 underscore names. So var.ec2 underscore names is a variable. It has a 3 values now. It will pick the values one by one. During the first loop, it will take the first value. On the second loop, it will take the second value. So once this is done, then all other options can be same, and the instance type already we have implemented the conditions. Let it be the same because we are going to create the environment for dev. But anyway, the condition will be false. So my instance will be t2.micro. So let it be the same. In tags, we have already used var.environment. So the name will be dev. Let's apply this. Before applying, let me destroy the existing instance. It's destroyed. Now we'll apply the configuration. This time we don't want to override the environment. Resources created. Now if you go to your EC2 console and refresh the page, you can see 3 instances, 3 servers. All instances are T2 micro. And if you go to tags, the environment is dev. But here if you see the server names, it's all web server 1 because we have not changed the server name in the code. It is supposed to be web 1, app 1, db1, right? Okay, now what we can do is, again we can apply the logic. Already we have implemented the for each. So values are already in the for each parameter. So now we need to use the same type. The value is already set to for each. So now we need to call the value here for each value. Okay, so I will remove the string and instead I will just add each dot value. Let's apply this. Now refresh your page. Now if you see, the server names are changed based on the values. So for this dev environment scenario, we have got our 3 servers for our 3-tier architecture. Let me destroy it again. Now we will see count loop. So count is based on the numerical value. Instead of for each, I will just put count and equal to the value. Let's say 2. But here in the tags already we have implemented for each concept. So that is why we have defined this value. So we cannot use this one because we use count loop now. Since we use count with the numbers, what I will do, within this double quote, $count.index. It is not a count because count.index. Now the index will be 0. So what I will do, to make it easy to understand, I will add the prefix like dev hyphen. So my names will be dev hyphen 0, dev hyphen 1. It will be much better. Let's apply this. Refresh the page again. Now if you see the servers dev 0, dev 1. So we have given only the 2 EC2 instance to be created on the count. That is why we had 2 EC2 instance. Finally, built-in functions. Terraform has lot of functions that will help us to transform or manage our values. This is like a programming related things only, because it will have a string functions, numeric functions, collections, mappings, datetime functions, lot of things are there. We are not going to use all the things, but if we need it, then we need to find the respective function and we can implement it. If you search in the search engine like Terraform functions, so here is the link, functions. Here you can see all the functions. On the numeric function itself, you have this much of functions. Whatever you need it, you can use it. Lower, upper. Let's try to use one function on the same example. Here if you see the instance name, it's all in smaller case, dev hyphen. Let's say we want to change the value into upper cases. For that we can use a function called upper. So the names are dev hyphen 0, dev 1. But before that, if you see our instance, it starts from dev 0, dev 1. It would be good if that starts from 1, 2, 3 like that. Okay. So on that also we can apply a logic like I can add plus 1. If my index is 0, then it will add 1. So my ECD name will be dev 1. Similarly, for the next time, if the value is 1, then the ECD name will be 2. Again apply the configuration. And refresh the page. Now if you see, the names got changed. It starts from 1, 2. Okay, coming back to built-in functions, I'm going to change my server names to upper cases. Generally the function should be in this format, like function name, and within the bracket we can define these values. Already we have this value, just cut the value and we can use a function. Already it is lower, so I will change this to upper. Upper, within the bracket I will use a value. Remove these unwanted lines. So upper is a function. So again apply the configuration. Refresh the page. The names got changed into uppercase. This is how we use the functions. We need to find the respective functions and we can implement it in our code. So hope you have got an idea how to use Terraform conditions, loops and built-in functions. So in the next topic, we'll talk about Terraform state file management. So till then, keep practicing and have fun.
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.lanetguide.net.